Hello my dear students, today we will discuss how to draw SFT and BMD for simply supported beam. Okay, let us take one example. A simply supported beam of 4 meters span is carrying loads as shown in figure. Draw shear force and bending moment diagrams for the beam. Okay, this is the beam simply supported. You can see here this beam is rest on two supports, right? A and B. So these are the two supports, simply supported beam of span 4 meter carrying a load as shown in the figure, 1 point load and 1 UDL of 2 kilonewton per meter. Okay. Now what we have to do here, see, this is slightly different from cantilever beam because cantilever directly I started with the finding shear force and then I calculated bending moment. But here first you have to find the reactions. What is RA and what is RB? First find the support reactions. So how to calculate that? All of you know that you have to apply the conditions of equilibrium, that is summation of vertical forces is equal to 0 and horizontal forces equal to 0 and moment equal to 0. But here there is no horizontal force. So you can apply only two conditions, right? First we will consider summation of vertical forces equal to 0. So here sign convention is upward is positive and downward is negative. No left side, right side. Okay, here it is just you have to consider the force reactions. It is not shear force. Okay. So how to calculate? Now RA, this is plus. Okay. So shear force at reaction at A, RA, that is plus RA, then plus RB upward direction plus RB, and then minus 4 downward direction minus this is UDL. So convert into load, that is 2 into this distance. What is this distance? 1.5, 1.5. So this distance is 1 meter, correct? Because total is 4 meters. So this is 1.5, 1.53. So this is 1 meter. So 2 into 1. So that is equal to 0. So write in terms of RA plus RB, that is equal to minus 4 minus 2, that is equal to 6. Okay. Now let us consider this as the equation 1. Okay. Next take moment about A or B. I'll take moment about A. Okay. So and equate it to 0. So summation of moment about A is equal to 0. Here you have to consider clockwise is positive and anti-clockwise is minus. This is not bending moment. This is just moment you are finding the reactions. Okay. Clockwise positive, anti-clockwise negative. No right side, no left side. Okay. So what is that now? RB here, this is, I take moment about A. So RB is moving like this direction. So that is what? Anti-clockwise direction. About A, it is moving in the anti-clockwise direction. So it is minus RB. This is vertical. So perpendicular distance is 4. So minus RB into 4 plus here this is like this downward direction, this UDL. So that is moving like this direction. So that is clockwise. So 2 into 1 into half of this you have to take, that is what? 0.5. About A we are considering. So 0.5 plus 1.5 here, this term. Okay. 2 into 1 into half of 1, that is 0.5. Plus till A we are considering, so plus 1.5. Okay, next load is this 4. So minus plus, again this is moving like this direction, that is clockwise. So clockwise is plus, so plus 4 into 1.5. Okay, that is here. So simplify this, that is equal to 10. Okay, simplify this. So you get RB is equal to 10 divided by 4. That is equal to 2.5 kilonewton. Okay, this 10 is equal to, this when I substituted this and this will get 10. So RB is equal to 10 divided by 4. That is equal to 2.5. Once if you know RB, you can calculate RA. How? Substituting this equation. RA is equal to 6 minus RB, that is 6 minus 2.5, that is equal to 3.5 kilonewton. So RB is equal to 2.5 and RA is equal to 3.5 kilonewton. This is the first step in the case of simply supported beam. Next, we'll find what is shear force at different points and what is bending moment. Okay. So first calculate shear force. What is shear force at B now here? Shear force at B, that is here. This consider shear force at B. This is now right side. I'm considering from the right side. So right side upward, that is negative. So I've told that sign convention, right? Right side upward negative and suppose right side downward is positive, so only consider from the right side. So this is right side. Shear force at B is minus RB. This is RB and this is RB and this is RA. Okay, so shear force at B is minus RB, that is equal to minus 2.5 kilonewton. So minus 2.5 kilonewton. Next, shear force, just write to D. What is shear force? Just write to D. Here there is no load, nothing. So shear force at D also it is shear force. Just write to D also it is 2.5 kilonewton only minus. Then shear force at D. Again it is minus 2.5 because here there is no point load, nothing. So shear force at D also minus 2.5 kilonewton. Next, shear force, just write to C. What is that? Minus 2.5 till here, minus 2.5 plus, because this is right side downward, so plus 2 into 1. Okay. So minus 2.5 plus 2 into 1, that is equal to minus 0.5 kilonewton. Next, at C. What is at C? Whatever the answer, what is that answer? Minus 2.5, okay, minus 0.5 you get, minus 0.5 plus 4. Why plus 4? This is, I consider from the right side. So right side downward is positive. So plus 4. So what you get? You get it is equal to minus 0.5 plus 4, that is equal to 3.5 kilonewton. Next, shear force, just write to A. What is that? Here there is no loading, nothing. So whatever at C, the same thing at A, at right to A and at A also. Okay. I hope all of you understood. So first, shear force at B is minus RB, that is minus 2.5. Then at D also minus 2.5. Then right to C is minus 2.5 plus 2 into 1, 2. So you get minus 0.5. Minus 2.5 minus 0.5. Then shear force at C is minus 0.5 plus 4, that is you get plus 3.5, and shear force at A is equal to plus 3.5. Next, let us consider bending moment. What is bending moment at B? So it is bending moment at this point. Again, at the support always bending moment is equal to 0 when it is simply supported beam. Okay. Now at B, bending moment at B, here there is no perpendicular distance, so force into 0 here. So at B it is 0. Next point is at A, bending moment at D. What is that? RB, that is like this direction. I consider from right side, this is plus, correct? So this is plus and this is minus for bending moment calculation. Okay. Now RB is moving like this in this direction. So it is plus. Plus RB into 1.5. Okay. Plus RB into 1.5. RB is equal to 2.5. 2.5 into 1.5, 3.75 kilonewton meter. Next, at C you have to calculate. What is at C here? RB into this distance, that is 1.5 plus 1, 2.5. So RB into 2.5, the direction is plus. RB into 2.5 minus, this is acting like this direction. So that is minus 2 into 1 into 0.5. Correct? So 2 into 0.5. Right? 2.5 into 2.5, that is this distance, 2.5 into till C, that is 2.5, 1.5 plus 1, minus 2 into 1 into half of 1, that is 0.5. Okay, so you get this 5.25. Next, bending moment at A. You have to get bending moment at A is equal to 0, because always in the case of simply supported beam, bending moment at the support is equal to 0, but you do that calculation. How to do? RB, that is direction, is like this, plus RB into full distance 4 minus, this is like this, it is moving to minus 2 into 1 into zero point 0.5 plus 1.5 minus 4 into 1.5. Okay, so like this. At A is 2.5, that is RB into 4 full distance minus UDL 2 into UDL of distance is 1 meter into half of 1 meter 0.5, but till A we are considering 0.5 plus 1.5 minus 4 into 1.5. So you get at A is equal to 0. Okay. Next, what you have to see, always maximum bending moment will occur where the shear force changes its sign. Okay. See, we'll see here where it changes. Now we'll draw the diagram. Shear force at B, that is equal to minus 2.5 kilonewton. So below the line is minus, above the line is plus. So draw at B, it is minus 2.5. Next, at C also, at D also, it is minus 2.5 only. Next, at C, it is 0.5 minus. So, but see, this is UDL, so it has to go like this. When there is no load, you get like this line. Okay, if it is UDL, you have to go like this, inclined line it is. So it is now 2.5 to 0.5. Then at C, what is at C? It is at C, it is minus 0.5. Then at right to C, at C it is 3.5. It is plus 3.5. So go up, because it is plus 3.5. Here it is minus 0.5. This is right to C. Okay, then at C it is plus 3.5. Then between A to C also 3.5. At A also it is 3.5. So see here, there is no load, nothing. Therefore you get this rectangle. Okay, here also. But here there is UDL, so you get like this line, inclined line, UDL. Okay, this is SFT. Next, draw bending moment diagram. At B it is 0. Then at D it is 3.75. Here 3.75 plus. And at C 5.25. Okay, 3.75, 5.25. Then at A again it is 0. Okay, so here B to A, B to D is straight line. This is straight line. But D to C, this is parabolic. Okay, this is parabolic because shear force diagram I have told, that is parabolic curve. If UDL is acting in the beam, then you have to consider parabolic shape. So this portion is parabolic, and then here 5.25. Again at A it is straight line. 0. Okay, all are positive values, so plus. Now, where is the maximum bending moment? Where shear force changes its sign, there will be maximum bending moment. Where shear force changes its sign, see here it is minus, here it is plus. So, at C, shear force changed its sign, minus to plus. So, maximum bending moment will occur at C, that is at C means maximum bending moment is equal to 5.25 kilonewton meter. So like this, you can draw SFT and BMD, and also you can find where is maximum bending moment and what is maximum bending moment. Okay, I hope all of you understood. We'll take one more example in the next class. Thank you.